Hello and welcome back to solving trigonometric equations. We're on to lesson 2. We're going to solve equations of the form a cos squared x plus b cos x plus c equals 0, or a sine squared x plus b sine x plus c equals 0. So hopefully we're looking at thinking, oh, it's just a quadratic. That's like x squared at x plus something equals 0. So it's back to a bit of factorizing from National 5 really, except this time we have cosine x or sine x in the bracket rather than just x. So let's have a look at number 1. So working in radians, always have a look to see if you're working in radians or degrees, that's important. So we have 2 cosine squared x minus cosine x minus 1 equals 0. So at the start of each bracket, I will have to have a 2 cosine x and a cosine x, because 2 cosine x multiplied by cosine x equals 2 cosine squared x. Now, if you're not so keen on that, guys, I don't really suggest this, but maybe just to do the first few questions, think of 2 cosine squared x minus cosine x minus 1 equals 0 as 2c squared, where c equals cosine x, minus c minus 1 equals 0. If you choose to do it this way, you must make this statement here on this line. If you don't, if you just go from this to this, you will drop a mark in an assessment. And when you get down to this line here, you must then write this after it. Okay, we must go from there to there if we choose to do this. Okay, so back onto this. So 2 cosine x times cosine x is 2 cosine squared x. Now I've got a 1 here, I've got a minus 1, but it's going to be a 1 and a 1 in the bracket. So when I multiply 2 cosine x by 1, I get 2 cosine x. When I multiply 1 by cosine x, I get cosine x. So I have a 2 cosine x and a cosine x. I need to make minus cosine x. So that would be cosine x minus 2 cosine x. So where did that minus 2 come from? It came from this term here multiplied by this term. So this must be a minus and this must be a plus. Okay, so this is why you guys done lots and lots of work on the essential skills and factorizing earlier on in the course, so you should be efficient in this and secure and be able to do this quite quickly. If not, go back and do some more practice. So we factorize. Now from here, it's just the National 5 skills again. So we need to solve 2 cosine x plus 1 equals 0. So subtract 1 from both sides, divide through by 2. So cosine x equals negative 1/2. Find the inverse cosine of a half. Remember, we are working in radians, so it's not 60 degrees in this case, it is pi by 3 radians. And we have a negative value of cosine, so we're looking in the second and third quadrant. So we're looking in the quadrant where only sine and the quadrant where only tan is positive. So it'll be pi minus and pi plus. So again, guys, if we're thinking in degrees, that's 180 minus 60, 180 plus 60. But write your answers in radians. So pi minus pi by 3, so that's a whole pi minus a third of pi. So you're basically doing 1 minus a third, which is 2/3. But you're doing a whole pi minus a third of pi, so that'll be 2/3 of pi, or 2 pi by 3. And in a similar way, 3 pi over 3 plus pi by 3 is 4 pi by 3. So that is 2 solutions. We are also going to get solutions from cos x minus 1 equals 0. So add 1 to both sides. The cosine of x equals 1. When does that occur? So I'm just going to sketch my cosine graph for this. The graph of cosine x is at a height of 1 when x is 0, and also when x is at 2 pi, or if we're thinking in degrees, 360 degrees. So quick look at the inequality signs here. Do we include this? It says, well, x is greater than 0, so I don't include 0. It also says x is less than 2 pi, so I don't include 2 pi. So neither of those are in the domain. So my final answer would be 2 pi by 3 and 4 pi by 3.